Now welcome to the stage, researcher at the University of Houston and Google Cloud GDE, Rabimba Karanjai.
Thank you, thank you. Since I'm the only one standing between this and what's going to happen next, I'm going to try to make it a little bit lighthearted. So, hi everyone, I'm Rabimbo, and today I'm going to talk about from whiteboard to users, what a graduate researcher kind of has to go through to take a research problem and pass it to, first, I need a clicker. Which works. Back. So from research to solution. Now, this did not start in a way where I had planned to do something like this. It started more like this. So when all of you think back about your own grad life, you'll remember a couple of things we are always lacking. One is probably sleep. The other one probably is budget. Now, one fine morning, my advisor walks in and he asks me that, okay, here is this SUI Foundation. They have a call for research paper, call for grant. Can we write a grant for them? Now, the first reply I had was, what is a SUI Foundation? What are they? If I have to write a grant, what am I writing? That's kind of how I was thinking. That's my normal state. Now, going back, I did my own research, which essentially is just Googling that, okay, type SUI Foundation. Okay, it came up with a couple of names, couple of more names. So something came up as Mission Labs, which apparently funds SUI Foundation. I said, okay. And I clicked on it. What came up was similar to what google.org and google.com is. So Mission Labs apparently is founded by these three people, and they came out of Facebook. So some of you might remember Facebook had an ambition once upon a time to create a decentralized payment platform. And they were creating their own blockchain, their own programming language, which was Move. It was called Liber, and then they came out because then Facebook decided, nah, not gonna do that. So they came out and they created their own foundation and started their own company, and which was Move. So since I had that, I wanted to write the proposal. Now, before we write a proposal, I wanted to give you a kind of background on what Move is and what's actually going on. So before even going to the research problem, the main story was Move is a smart contract language. How many of you have at least played with cryptocurrency or know about blockchain? Awesome, quite a few. Now, if you are deploying any contracts, these are called contracts, they are very specific programming paradigms which are deployed in a blockchain, which gets executed and money gets sent, cryptocurrency gets sent to another wallet, which is where you get your money. And that they are all coded in a programming language, which is called smart contract. Now, there are a lot of smart contracts. One very popular one is called Solidity, which is Ethereum-based smart contract. And SUI has its own smart contract language, which was called Move. Now, essentially, it's a code generation problem. So can LLMs generate code? So if we see, when I was looking at this research, LLMs can already generate code. If you look at your own LLM, whatever it is your choice, on the left, I will not name what LLM that is, but you probably are familiar with that. So all of them can generate code. And you have seen in talks today here how well they are in generating code. So why is this a problem? This is a problem because smart contracts are not like any other programming language. Now, why are they different? First, they are less in representation. So if you look at whole GitHub, how many codes of Solidity you will find, how many numbers of Move code you will find will be magnitude less than other programming languages which you can find. So we can call these low resource coding languages. So before we even start writing a grant, I have to first see that, okay, is the existing solution is good enough already? So we wrote a kind of overall paper which looked at state of the art at that time to see that, okay, is GPT, is Gemini, is all the other, not all, some of the other open weight models, can they generate Solidity code? We did not go to move yet. We just looked at Solidity because Solidity was pretty popular. You had enough codes available. And what we found out was that it's pretty bad at generation. If you want to read this, we published this in ICBC 2 years back. So if you want to read more about it, you will see they were able to compile only compilable code, only like 36% they were able to generate. So with that, we have a pretty good use case that, okay, the LLMs are pretty bad at Solidity code, and it's pretty pathetic at generating move code. So at the time, we could not generate a single compilable move code using state-of-the-art, all of the models. So we started to write the grant proposal. Now, the interesting thing is, we also probably should not commit to the fact that, okay, we're going to do a research which is going to produce something which can generate move code, which state-of-the-art cannot. So we took a step back and wrote a code translation proposal where we take a specific smart contract in Solidity and translate it to move. A long time later, we got an email that, yes, we got through the application and we got the grant. So if you look the overview of proposals, the second one should be ours, where we got the grant for do the work. Now, that's all and fine. When we worked on it, eventually we got the paper accepted, and we were able to do it. So what we did was that we took us a specific old Solidity smart contract, and we were able to I won't say transpile, but we were able to translate it to move smart contract, and which we could prove formally that it is right. So it was fine. We published it in FSE, and I gave a talk about this in Berkeley RDI last year. So we are very happy. My advisor is happy, but the grant is running out. So before the grant ran out, this is how the architecture looks like for our Sol mover. We had a couple of research questions. If you look at that, how we solve a LLM which we cannot pre-train or cannot fine-tune with code. So the main research problem was that we don't have enough move code in GitHub. So at that time, you had roughly 1,000 pieces of code available, .sol file, in whole GitHub, which are .mov file, which are written in move. And you cannot use that for pre-training. You cannot use that for fine-tuning. It just won't work. So we adopted a double LLM approach where we coined something called concept. I will talk about that later. It's not really the concept we think about. But we encoded something through which the LLM tries to generate the code based on coding rules instead of tokens. And it wasn't a perfect work, so we had to do an iterative repair on the code based on both the compiler feedback, and also we wrote a formal verifier for move, which gives us feedback if the code is correct or not. Now, that was awesome, but I was running out of grant, and SWI Foundation was very happy with our work. They came back and said that, okay, do you want more money? My advisor said yes. And they said, okay, then give us something which generates move code. And I was not happy, because what I found out while trying to do the research for the previous one, that to my knowledge and to the resources I have, it probably wasn't going to be possible. But we wrote the CFP, wrote the grant anyway, with the fact that, okay, we take it as a multi-step approach. We take it one hurdle at a time, and we specifically wrote that, okay, these are the things we are going to do. So with that, going to stage 2. So why it was more of a problem for move? By this time, these LLMs were good enough to produce smart contracts for Solidity. They were not correct all the time, but a lot of smart contract developers I knew were actively using LLMs to generate the code. I will not talk about the flurry of news that came last 1 year for different blockchains getting hacked, but yes, people are using that. So why Move is different? So Move is based out of Rust. So it takes a lot of things from Rust, but it changes a lot of things which is available in Rust but not available in Move. It creates a very interesting challenge. If you try to do any kind of RAG, zero-shot generation, or anything where you try to train it, you will get a code. We were getting a code which looked very much like Move, but will not compile because it has things from Rust, which it should not have. So to deal with that, I realized I am not good enough Move developer. I mean, I learned Move because of the project, but that's not good enough. So I need somebody who can help me understand the nuances of Move, who knows Move very well. And I met Sam. So Sam, if you remember my second slide, is one of the founders, co-founders of Misten Labs. He also is the creator of the Move language. So he knows Move, and I don't. So the best part to collaborate is, of course, meet up in a pub and pitch him that, okay, you probably don't know me, I know you, because you are funding me. And this happened 1 year back in ETH Denver. If any one of you know about ETH Denver, it's a huge, very interesting conference for smart contract blockchain enthusiasts. So we met, we planned we would collaborate, and I probably cannot go back. Thank you. Yes. We plan to collaborate, and then I realized I also need resources to make it. And then I realized I'm a Google developer expert. One of the good things we have is credits. So I kind of reached out that, can I have more credits? And I reached out to a lot of people who are in this room, and they provided me credits, and here we are. And here we are. That's a line from the papers we are publishing right now. So you will see it acknowledges not only Sui Foundation for the grant, but also Google, and specifically the GDE program, because without them, the paper probably won't be here, at least not right now. Now going forward, now we have the money. I have money again, and the expectation is even more. And the expectation is something which, even when writing the call for paper or writing the grant, I realized I might not be able to do. So time to go all in. So we started taking step by step. So here we have 3 papers which came out of this grant. 3 works. I'm gonna go very briefly into them. So first is collaboration is all you need. I don't need to remind where I got that inspiration of the name. But yes, this is accepted in FSC this year, and where somebody from our team is gonna present that, because again, I probably should not go out to present that right now. And then we also had another paper called Smartify. That's a multi-agent framework for automated vulnerability detection and repair. This, we did it before ADK came out, but now we are converting some part of it using ADK. Now, let's dive a little bit into what Smartify does and what the first thing is. So first, to go into how we even came to these conclusions for multi-agent system, for swarm system, is that can LLMs reason or plan? We have been told, and we have been using reasoning models for quite some time now. And these are the claims that, yes, LLMs can reason, they're very good at reasoning, good enough at reasoning. But I have a little reservation there, and what I want to believe is that they can reason, no, they can plan. We can encode planning. So if you look at this slide, if you look on the left and the right, left is what I think how we reason. So you have a system 1, which has relative knowledge about the environment, what's happening here, I have 5 minutes left, this kind of information. System 2 takes these information and kind of like tells me that, okay, you need to go fast, you need to go slow down, and based on this loop, it actually works. Now, if you look on the right, the environmental data is your pre-training data set and also very specific fine-tuning. Other than that, if you have to encode environmental data, those are what we are doing using in-context learning or dynamically just injecting information in our prompt. Now, these LLMs kind of tries to reason or kind of tries to guess what is going to happen based on this on a very high level. It does not have a system 2 to kind of go back and forth and validate that. So if we want to go one step up, you can say LLMs can approximate retrieval based on their guesses. So one thing is interesting is for between us and LLM is that complexity does not matter. So LLM is going to give you, unless it goes back and forth in a self-refined loop, it's going to give you the same amount, it's going to take same amount of token, it's going to give you the same amount, take same amount of time, if it's a NP-hard problem or a solvable problem. So it's not going to matter to the LLM. Now, contextual knowledge is much easier for a LLM to work with than us. We cannot hold, right now, I cannot hold the knowledge of what's happening in whole California, but I can work on what's happening in this room. So based on that, LLMs, this is my opinion, LLMs can't reason or plan, but they can help in the planning process, given we encode specific rules into their planning path. So back to the research question. Can it understand move? Why it has to understand move? It has to understand what is allowed in a move language, which is not a Rust, but based on Rust. And it also has to understand that is that allowed in a very specific version of move. While I was doing this research, something interesting happened is that move did what Python 2 and Python 3 did. They came up with a version which does not follow some things the previous version did. Now, I already had very less amount of data to deal with. And now that half of that data is gone, not gone, it's not immediately usable for me. So we had to encode very specific things so that it can reason based on which version, based on that version, can it apply those rules, and that rule feedback on top of that. So this is architecture of Smartify, where it tries to apply the same logic to understand if there's a bad code or good code, and if there is a bad code, is that a bad coding practice, or is that a vulnerability? And if it can detect that, it tries to patch it. So it generates code patches to repair that. How we validated is that we had a static analysis tool, and we had our own data set where we ran the tool and found that, okay, this data set had this number of, it is probably has 45 security vulnerabilities detected. And then we ran it through our framework, found Smartify, found how many of them, which is roughly 37 out of 45. And then it could patch it. So it is, yes, it's not perfect. We could not make it perfect. But whatever it caught, it was able to patch it. And next time when we ran that through our static analysis tool, it was fine. Now, what about, these are all research, fine. So Foundation is happy with research. Mistral Labs is not. So they want to eventually make it to the production. So this is a series of events that happened. On the left, you will see somebody was asking in X that, okay, when will we get these tools? And Sam tagged me that pinging Ravimba. I was like, wait, what? And then I got dragged into a call where we were that, okay, we need to make it. Long story short, I got to the pain to understand what it means to convert a research problem to an actual product which can be implemented in Cursor, Z, VS Code, and something else. And I gave a talk in their SUIME base camp on that. But yes. So going forward, if you are interested in the research aspect of it, these are the papers which came out of all my adventure with them. And they're all available. All of them are available in archive. And if I forgot to link the archive, instead of I linked ACM or something, just search with the name, it will go to archive. And with that, I want to give a shout out to all my other GDE friends who kind of, and Madhusha, who kind of pushed me that, okay, make your slide, make your slide. And I was procrastinating, so this is what I made. If you want to make a slide like this will take away a collab, which will create a slide like you for this with all the stories. Thank you. And